I'm Julian Shaji. My talk is Publishing Well-Found Python Packages. Hi, welcome to my talk, Publishing Well-Found Python Packages. Before we begin, let me say, the source of the images that I have used in this presentation are linked to the images themselves in the slides. We can share the link for the slides later on. So what do I mean by a well-formed package? A package that has attained some sort of a structure by adhering to some guidelines and practices, which makes it easier to work with and makes collaborating with others on the project a more fruitful experience. Making changes to such a package is less likely to be chaotic. It can be adapted to match the changing requirements with significantly less effort. But how is it possible? How can we make our project better formed? Sufficient documentation, tests, and readability are some of the key factors in this. A good first step towards making your package well-formed is by adopting a coding style and by using linting tools. It's good to have the suggestions mentioned in PEP 8 in mind. Consistent formatting has a significant impact on the readability of your code. And this will help us weed out a lot of bugs as it can make bug-inducing code snippets more prominent so that it will catch our attention and or that of the tools that we use, and we will be able to attend to it faster. But it should be noted that PEP 8 itself says that its suggestions should be taken more as guidelines rather than steadfast rules. This is probably applicable for the coding style that you adopt as well. For example, consider a long link that you have in your code as a sort of reference to some website, possibly in a comment or something. And your coding style specifies a line length limit of say 80 characters, and if your link is way beyond 80 character limit, instead of splitting that link into 2 lines or something, it's probably better to create make an exception for your coding style so that it will remain a single link, and whatever editor that you're using can still recognize it as a link, so that you can go directly to that link by just clicking on it instead of first joining them together or pasting it or whatever. Pylint and Flake8 are among the prominent linting and style tools used in Python packages. Both are very much configurable, although the default configuration can be used as a good starting point in your project. And then there's Black. If you don't want to spend too much time fixing and formatting all your code all the time, and don't mind letting an external tool take control over your code formatting part, you can use Black. It is becoming more and more popular these days. It can automatically reformat your code for you so that regardless of the style that you use to write your code, that you use to actually write your code, after applying Black on it, it will just look the same as Black outputs it. This is often helpful if a lot of people are collaborating together on your project and you want all the code to look the same. Another mechanism that can help is static type checking. Python had been supporting type annotation for quite some time now. Making use of it not only improves the readability of your code without having any effect on the code execution part, but it also enables us to run static type checks. In a way, we can have the advantage of a statically typed system in Python as well. These checks often help to reveal certain subtle bugs that would be very difficult to figure out otherwise. MyPy, PyType, and PyArray are some of the prominent static type checking tools available in Python we have right now. Let us use an example to illustrate the advantage of MyPy and type annotations. I have a function here named add, not a good name, but which accepts 2 arguments, x and y. If x boolean value is true, it returns the value of y as such. Otherwise, it adds 10 to y and returns it. But looking at this, we have no idea what kind of values x and y are. Here I have passed two integers as arguments to the function, but x could be a boolean, a list, or anything. It could be anything. No matter what we pass to it, it could be anything. So we have no idea what the correct argument should be, and as of now we have no mechanism to check it as well. Contrast it with the version that we have on the right side. Just by looking at it, we can say that x is a boolean, y is an integer, and the function as returns int. Right? See what a difference it made. It's a lot more readable. Don't you agree? And running MyPy on this example in the updated example that we have on the right side would lead to this error. Argument 1 should have been a bool, and instead of we got an int. So MyPy can catch such kind of, it could happen by mistakes, stuff like this. MyPy can easily catch them, and usually the outcome of these bugs you will experience only when actually executing this program. But MyPy can do that without even executing it. It's that. Another concern is dead code. As a project evolves, it's bound to have some dead code accumulated along with it. This dead code could interfere with the rest of the code and can lead to unexpected results because of this interference. We can use tools to help us identify dead code so that it may be removed. Vultr is such a tool. It does static analysis to figure out which objects may be unused and reports it along with its confidence score, how confident it is that that object is unused. Vultr is quite fast as it doesn't need to actually execute all the code, but identifies the unused parts using Python's abstract syntax tree. Before mentioning unit testing, let us talk about a project's layout, its directory structure. Two of the most commonly seen structures used by the Python project are the flat layout and the SRC layout. The flat layout, as you can see, has the source code and the test in the same directory level. In this case, the source code is mentioned inside the package name directory and the test in the test directory. But the SRC layout adds a nesting to the directory and adds another directory level to store the source code. Usually the name of the outer directory is SRC, and within which the source code is provided inside another directory. But that said, there is no officially recommended layout for when choosing a layout for your project. You may choose a layout that fits your need better. Check out these links to see some interesting arguments regarding a project layout. Now comes unit testing. Of course, it's important to check if your code works as you expect it to work. Otherwise, there would be no point, right? But for the sake of unit testing, it is helpful to design the code so that different functionalities, the major functionalities, are divided into separate testable functions. There are a lot of testing and tools and frameworks available for Python. Among them is the built-in unit test and the third-party PyTest, which is widely used. So let us consider a simple example to illustrate the use of testing. I have here a simple function strcmp, which takes two strings str1 and str2, finds the ratio of their lengths, and returns a boolean based on that ratio. Here I have on the right side the test that I have written for this tiny function. I have the string values and the expected return values specified using the parameterize from PyTest. And once I ran it, I got the error that I have shown on the bottom side. So I got a zero division error. So why is that? Because if the second string, the str2 string's value is an empty string, the division will here be a divide by zero division, so it will lead to an error. I had not considered that while writing that function, and writing appropriate test cases let me know that there's something wrong, something that I had not considered earlier when I wrote the function. So I will be able to fix that, because now I came across that in the testing phase itself. If I had not done the testing, I would have given it out to others, and they would have come back to me with complaints, right? Yes, something like that. But writing test cases alone is not enough. We should know that the tests that we have written have cover all the cases. I mean, all the desired parts of code should be covered. Otherwise, there will be little point in writing the test, right? So that's where test coverage comes in. 100% coverage is ideal and desirable, but it may not always be possible. There are some projects, for example, Vultr, that we mentioned earlier, has almost 100% coverage, but that is not always possible due to various reasons. So coming to tools that can be used to measure test coverage, there is coverage.py, a standalone Python package, and there's also PyTest Co, a plugin for the PyTest module that we discussed earlier. Both are quite popular. Well, let us consider another simple example. We have a function foo, which accepts an integer n and returns a boolean. So it basically returns true if it's the number is an even number, otherwise false is returned. But note that my test case covers only the even part, the odd part, the condition where the function foo accepts an odd number is not actually tested. So running coverage in such a situation will give you this output that you see on the right hand side. They say coverage is only 75%. 3 lines were run, 1 is missing, and the missing line is highlighted in the red background. The coverage can generate HTML reports, so this is the output that I got from that. But once I fix that and I update my test to cover the odd input as well, I run coverage again. Now it says 100% coverage. So now we have a lot of tests to run on the package, right? From Pylint, MyPy, Vultr, PyTest. So a lot of tests to run, a lot of checks to be run on your package. So we can definitely use a test automation tool to run all these tests. And also we need to test on all the supported Python versions and Python implementations. So we can use maybe your package is designed to run on even on PyPy, another implementation, not CPython. And you need to verify that your package works on all the supported Python versions. Maybe suppose that you used the Walrus operator, which is available only on from Python 3.8 onwards on your project, and you want your project to support even on Python 3.6. So you were unaware that you actually used the Walrus operator, and you run the talks test, the test automation test, and you will find that you have an error in 3.6 but not on 3.8. So you will know what to do. Talks and Nox are some of the prominent test automation tools that we have in Python. So the test automation tools can be used to run the test locally, or maybe even with the continuous integration services that you use, whichever ones that you use. Remember what I mentioned about the possibility of flat layout packages running into problems while testing? Well, that's because tools like Talks creates virtual environments just to run your tests so that they are tested just like they were installed, like in your user machine. But if you have a flat environment, The source code itself could be imported from the test instead of the package that you have had installed in the virtual environment that the Tox or any other test automation tool like that created for you. But a SARS layout doesn't have this problem, as the source code itself cannot be directly imported from the test directory because it's inside yet another directory level. So that eliminates the possibility of an accidental import like that is possible in a flat layout. Once you have your project ready, you can build and package it so that you can share your work with others and let them use it. The build process would create files that can be used to install your package in other machines, like the wheel file, for example. There are several tools in these days that can be used to package your project, like setup tools from PyPA, the Python Packaging Authority, or the newer non-PyPA tools like Flit and Poetry. The next step after packaging a project is publishing it. If you're using setup tools, you can use the Twine package to upload it to the server of your preference. In the case of Flit and Poetry, they can do the publishing by themselves. People commonly upload their packages to the PyPI server, but if you are publishing there before trying the actual PyPI server, you can try out the test PyPI server, which is a place to try out your package and see if all is well before publishing to the actual PyPI. Other than the tools that I mentioned so far, there are a lot of other tools that you can use that can be used to make your package better. For example, there's bump version, which can be used to change your Python package's version. And there's pre-commit, which can be used to run commands before committing. ISO to sort your imports in your Python source files. And cookie cutter, especially handy if you're using setup tools to start your project. Once you have your package ready, test all set up, you could use CI/CD to run the test automatically. You can even, depending on the CI/CD service or tools that you use, you can even view the results of the past test and all, which can be quite helpful. So now, due to some proposals that have been accepted by the Python community, the pyproject.toml file has become the center point of the Python packages. Earlier, it used to be just setup tools. Now you can actually choose your build system to be something else if you like. And because of the toml file involved, we can probably expect a toml module inside the Python language standard library itself, because a lot of projects will need that to parse the pyproject.toml files content. Most of the packages that I have mentioned, those packages configuration files used to be separate, so there will be a different configuration file for each tool. It used to be like that, but a lot of projects and a lot of such tools have moved their configuration part to the pyproject.toml file. You can configure the tool in the appropriate section within the toml file itself. While some projects are yet to make the move, we can expect them to make that move in the near future. So we have come to the end of the presentation. So a quick recap of what we saw. We talked about the linting, we talked about static type checking, dead code identification, testing and test coverage and test automation, and the packaging part. Follow the practices promoted by these tools, and your project is bound to be better formed. Thanks for being here.